Your AI coding agent does not need more power, it needs less permission. That sounds backwards, but it is the next big shift in AI coding because right now developers are plugging agents into terminals, files, databases, GitHub, browsers, Slack tickets, cloud accounts, payment systems, and random tool servers they found 5 minutes ago. Then they're acting surprised when the agent becomes the most dangerous thing on the machine. The model is not the scary part anymore. The scary part is the tool it can call while you're looking at another tab. And this is why WebAssembly, WASI, and tiny isolated runtimes are suddenly much more important than they look. Not because they make AI smarter, because they can put the AI tool in a tiny prison. No home folder, no secret keys, no surprise network access, no ability to wander through your repo unless you gave it that exact room key. The future of AI coding is not just better agents, it is agents that can do real work inside a box, small enough that you can trust the damage. Hey, don't forget to like and subscribe. Back to the video. For a long time, the big question in AI coding was simple. Which model writes better code? Claude, Gemini, GPT, Qwen, Kimi, DeepSeek, local models, paid models, cheap models. That fight still matters, but it is no longer the whole story. Because the moment an AI stops being a chat box and starts being an agent, the problem changes. A chat model can say something wrong, an agent can do something wrong. That is a completely different risk. If the model hallucinates an answer, you might waste 10 minutes. If the agent hallucinates the correct command, it might delete a folder, leak a token, rewrite a config file, or push nonsense into a branch that other people now have to clean up. The old AI problem was accuracy. The new AI problem is authority. What is the agent allowed to touch? What can it read? What can it write? Can it call the network? Can it see environment variables? Can it read the whole repo or only the files for this task? Can it run a package install script? Can it talk to your database? Can it open a browser and click buttons? Can it use a tool that was updated after you approved it? These questions sound boring until one of them is answered badly. Then they become the whole story. MCP is one of the biggest reasons this matters. Now, the Model Context Protocol took a messy problem and gave it a common shape. Instead of every AI app inventing a custom integration for every database, ticket tracker, repo host, file system, or cloud service, an MCP server can expose tools, resources, and prompts in a standard way. That is genuinely useful. It means your AI editor can connect to more of your work. It means one tool server can be reused across different clients. It means developers can stop writing the same glue code again and again, but every useful abstraction also creates a new place to hide danger. MCP tools are not just information, they are actions. They can query a database, they can create an issue. They can read a file, they can call an API, they can run some computation, and the important detail is that tools are often model controlled. The model sees the tool descriptions, decides which tool fits the task, builds the arguments, and asks the client to run it. That is powerful. It is also the exact point where developers need to slow down, because a tool description is not just documentation anymore, it becomes part of the model's decision-making. If that description is wrong, manipulated, overly broad, or quietly changed later, the model can be steered toward behavior the user never intended. This is why people talk about tool poisoning. The poison is not necessarily in the code the model writes, it can be in the instructions around the tool. That is a weird new attack surface. It means the dangerous part might be invisible in the friendly tool list. Developers already know this shape of problem. We saw it with NPM. One tiny dependency gets installed because another dependency wants it, then another package depends on that, then a build script runs, then a maintainer account gets compromised, then suddenly a package nobody thinks about is part of a huge supply chain incident. MCP can create the AI version of that pattern, except this time, the package is not just code imported by your app. It is a tool your agent can choose to call. That is much stranger. A normal dependency usually runs during build time or runtime in a predictable place. An agent tool can run because a model decided it was relevant. Maybe you ask the agent to fix a test, the agent reads the repo, it sees an error, it decides a database tool would help, it calls a query, it gets a strange response, it decides it needs a migration, it touches a file, it runs a command, then it asks another tool for context. That chain can be useful when everything is legitimate. It can be disastrous when one link has more permission than it should, and this is where the old developer habit becomes dangerous. Install the tool, approve the connection, trust the package, move fast. That habit made sense when the tool was a thing you clicked. It makes less sense when the tool is something an agent can invoke in the middle of a long task while juggling thousands of tokens of context. The tool layer needs a stronger boundary, not a nicer warning, an actual boundary. The obvious answer is containers. Put the MCP server in a container. limit the CPU, limit the memory, do not mount the whole file system by default, sign the image, ship a software bill of materials, make the user explicitly choose which folders or secrets the server can see. That is already a much better direction than random local scripts with full machine access. And Docker has been moving exactly this way with MCP tooling. That matters because it turns MCP servers from loose scripts into packaged things with isolation and provenance. It gives teams a place to say, this agent can use the GitHub server, but not the production database server. Or this project can mount this folder, but not your home directory. Or this tool can get 1 CPU and 2 gigabytes of memory, because a helper tool should not be able to melt your laptop. Containers are the practical answer most developers understand today, but containers are still a fairly big box. They are amazing for packaging applications. They are heavier than what many agent tools actually need. If a tool is only supposed to parse a file, transform JSON, validate a config, fetch a small result, or run a narrow function, giving it a whole container can feel like giving a screwdriver a warehouse. That is where WebAssembly starts to get interesting. Most developers still think of WebAssembly as a browser thing. Run fast code on a web page, compile Rust to the browser, do game engines and image tools and little demos. That version is real, but it is not the version that matters for AI agents. The important version is WebAssembly outside the browser. A small binary, a runtime, a permission model, a way to run code that does not automatically inherit the whole machine. That is the shape agents need, because agent tools should not start with total trust and then ask us to remember every possible failure mode. They should start with almost nothing. Then we grant exactly what the task requires. A file, a folder, an outbound network target, a clock, random numbers, standard input and output. Nothing else unless we say so. That is the mental model WebAssembly and WASI push toward. The tool is not born with your laptop's entire life story in its hands. The host gives it capabilities. No capability means no access. That sounds like a small technical distinction, but for AI agents it is huge. Because an agent tool with no access to your secrets cannot leak your secrets. An agent tool with no write access to the repo cannot rewrite the repo. An agent tool with no network cannot phone home. An agent tool with only one mounted directory cannot go wandering through everything else. This is the boring security sentence that becomes exciting once agents are everywhere. Default deny beats, please be careful. Every time. WASI stands for WebAssembly System Interface. That sounds painfully dry, but the idea is simple. If WebAssembly code is going to run outside the browser, it needs a clean way to ask for operating system style things, files, streams, network features, clocks, randomness, command style, input and output. But the key is that it should ask through interfaces the host can control, not by assuming it owns the computer. That is why WASI is interesting for agent tools. An AI coding agent does not need a tool that can do anything. It needs a tool with a contract. Here's what I can call. Here are the inputs, here are the outputs, here are the capabilities this tool gets, here's what it definitely cannot touch. In 2026, WASI 0.3 made this even more relevant because async support became native to WebAssembly components. That matters, because real tools are often not just one synchronous function. They wait on streams, they handle HTTP, they talk across boundaries, they combine smaller parts, they need to compose without every component carrying its own messy event loop story. So the direction is clear. WebAssembly is not just a format for tiny browser programs, it is becoming a portable component layer. And a portable component layer is exactly what agent tools want to be. Here's the rule I think more developers are going to adopt. The tool should be smaller than the agent. Not just smaller in file size, smaller in authority, smaller in scope, smaller in blast radius. If an agent wants to run tests, maybe it gets a test runner tool that can only see the project directory and only execute the allowed command. If an agent wants to inspect dependencies, maybe it gets a dependency scanner that can read log files but cannot write anything. If an agent wants to format code, maybe it gets a formatter component that takes files in and returns formatted files out without seeing your environment variables. If an agent wants to query production data, maybe the answer is no, or maybe it gets a read-only tool with filtered fields, rate limits, audit logs, and no raw secrets. This sounds slower at first. It is actually how agents become usable in serious projects, because the alternative is asking every developer to manually supervise every possible action forever. That does not scale. People get tired. People click yes. People trust the model because the last 10 tool calls were fine. Then the 11th one is weird. The answer cannot be endless pop-ups. The answer is smaller permissions. If the tool is trapped correctly, the approval screen matters less because the action physically cannot escape the box. That is the part most AI coding tools still need to grow into. This also changes how you should judge new AI coding tools. Do not only ask which model is inside, ask what the model is allowed to do. When a product says it has MCP support, ask where those servers run on your machine. In a container, in a managed sandbox, as a remote hosted server. Can the tool list change after you approve it? Can you see the exact commands? Can you restrict folders? Can you remove network access? Can you separate project permissions? Can your work project and side project have different tool profiles? Can the agent read environment variables? Can it call a tool without a confirmation? Can it write files by default? Can you audit what happened after the fact? These questions are not paranoia. They are the new version of reading the install script before piping it into your shell. And yes, almost nobody does that either. That is the point. Developer tools have always won by reducing friction. AI coding tools reduce so much friction that the safety model has to become automatic. If the safe path requires heroic attention, it will fail. If the safe path is the default shape of the runtime, it has a chance. That is why tiny sandboxes matter. They make the right thing boring, and boring security is the only security that survives real work. There is a catch: WebAssembly is not magic. Putting a tool in a Wasm runtime does not automatically make the whole system safe. The host can still give it too many capabilities, the agent can still make bad decisions, the user can still approve the wrong thing. The tool can still return misleading output. The model can still obey hostile text from a web page, an issue comment, a README, or a poison tool description, and some workloads still need containers, virtual machines, or full operating system features. Wasm is not a replacement for every sandbox. It is a sharper option for a very important class of agent tool. Small function, clear interface, limited permissions, fast startup, portable runtime, easy to run, the same way on a laptop, server, editor, or cloud worker. That combination is the interesting part, because the AI agent ecosystem is exploding in exactly the place where those properties matter. Thousands of small tools, lots of different hosts, many languages, different operating systems, developers who want one click, install teams that need policy, tools that should do one thing and absolutely not touch anything else. That is a WebAssembly shaped problem. The next mature AI coding setup is going to look less like a chatbot and more like a permission graph. The model sits in the middle. Around it are tools. Each tool has a narrow contract. Each contract has capabilities. Each capability has a reason. This tool can read these files. This tool can write this generated folder. This tool can call this API. This tool can run for this many seconds. This tool can use this much memory. This tool cannot see secrets. This tool cannot reach the internet. This tool cannot modify source files. This tool cannot run unless the project profile allows it. That is not just security theater. That is how you make agent work repeatable. A junior developer can run the same agent workflow without accidentally giving it the keys to production. A team can share approved tools without telling everyone to trust random setup instructions. A company can audit what the agent did without banning AI entirely. And a solo developer can experiment with powerful tools without turning every install into a trust fall. This is where the agent market is going to split. Some tools will keep selling raw power, bigger context, more autonomy, more tools, more actions, more everything. But the serious tools will sell controlled power. The agent can do the job, but only inside the boundary you chose. That is the difference between a clever demo and something you can leave running on a real repo. So what should you actually do with this? First, treat every agent tool like a dependency with hands. That is the phrase to remember. Not a plugin, not an integration, a dependency with hands. It can act, so it deserves more suspicion than a normal library. Second, separate your tool profiles by project. Your toy repo does not need the same permissions as your work repo. Your docs folder does not need the same tools as your production app. Your local experiment does not need access to every account you have. Third, prefer tools that are packaged and isolated. If a tool can run in a container, that is better than a mystery process with full local access. If a tool can run as a WebAssembly component with explicit capabilities, that may be even better for small, narrow tasks. Fourth, stop approving broad file access casually. The most dangerous permission in coding is often not some dramatic cloud admin role. It is read access to everything. Because everything includes tokens, config files, private notes, old credentials, local databases, and that one forgotten file you absolutely did not mean to share with an AI tool. Fifth, pay attention to the tools your agent can see. If the model uses tool descriptions to decide what to call, then the tool list is part of the prompt. That means the tool list is part of your security boundary. And sixth, expect this to become a feature race. Not just which AI app has the best model, which one has the best sandbox, which one has the clearest permissions, which one lets you see what changed, which one lets a team approve tools once and reuse them safely, Which one assumes the agent will make a mistake and designs the box accordingly? That is the product category to watch. The funny thing is that this makes AI coding feel less futuristic in one way. It brings us back to an old engineering lesson. Do not run powerful things with unlimited permissions. We learned it with servers, we learned it with containers, we learned it with browsers, we learned it with mobile apps, we learned it with package managers. Now we are learning it with AI agents. The difference is speed. Agents make decisions faster than a human can review every step. They connect more systems together, they read more context than we can keep in our head. They can turn one vague instruction into 20 real actions. That is exactly why the runtime matters. The next big improvement in your AI coding setup might not be a better model. It might be a smaller box, a tool that starts with no access, a permission graph you can understand, a sandbox that makes bad actions physically impossible instead of merely discouraged. That is not as flashy as a benchmark, but it might matter more. Because a smarter agent with unlimited permissions is not automatically useful. Sometimes it is just a faster way to make a bigger mess. The agent you can trust is not the one that promises it will never make a mistake. It is the one that can make a mistake and still stay inside the tiny prison you built for it. That is the future I would bet on. Not agents with infinite power, agents with exactly enough power